Alright then, let us read the question together. In the diagram below, C, G, F, B and the C, G, H, D are fixed walls that are rectangular in shape and vertical to the horizontal plane F, G, H. Steel poles erected along FB and HD extended to A and E respectively. Triangle ACE forms the roof of an entertainment center. BC is given to be equals to x, CD to be equals to x plus 2, B angle AC to be equals to theta, A angle CE to theta, and E angle CD is equals to 60 degrees. Now, you are given the information for question number 7 and you are also given the diagram that corresponds with the information that you have just been given. So without any waste of time, the most important information that you are given from the information, it is already been plotted on your diagram. You have given the sides, you have also given the angles in terms of theta, and you are also given this, the magnitude of this angle, and you are told that these are your rectangular shape. They are rectangular in shape, meaning these are the rectangles. Okay, now let us do the questions. They say to us, calculate the length of 7.1.1 AC in terms of x and theta. So because you are asked to determine the magnitude of AC, you go to your diagram, go look for AC. Where is AC located? AC, meaning AC, it is this length. Now, after locating the AC, check, is AC located on a triangle, or AC is located on a rectangle, or it's located on what shape? AC is located on two triangles. Okay, AC is located on this triangle, which is triangle ACE. It is also located on triangle ACB or ABC, meaning AC is a common side for both triangles. Now check which triangle has, because they say determine the length of AC in terms of x and theta. Between these two triangles, which one has both x and theta? This one, it has only theta, which is the angle of it, and this triangle, which is ABC, it has theta and x, meaning we're gonna use this triangle. Okay, and again, what have I taught you guys about the triangles? I taught you that if triangle, it has 90 degrees in it, in order for you to determine the sides and to determine the angles of the triangle that has 90 degrees, you're gonna use the Pythagoras theorem, or you're gonna use your trig functions. Okay, so it has 90 degrees. Definitely, in order for us to determine the length, it's either we use Pythagoras theorem or the trig functions. If we use Pythagoras theorem, we won't be able to get the length of AC because we don't have AB. We're supposed to have this side and that side in order for us to determine this side. That's Pythagoras theorem. But because we don't have AB, therefore we're gonna use the trig functions. We have the angle, we have the side. So in order for us to determine the AC, what are we going to do? Opposite over hypotenuse. So ka to a so SOH, opposite over hypotenuse, meaning we're gonna use sine. This is opposite over hypotenuse. For 7.1, we're just gonna say 7.1.1, we're just gonna use sine theta, which is equals to, in this case, opposite is BC and hypotenuse is AC. It's hypotenuse because it's opposite to 90 degrees, okay? Meaning we're gonna say BC divided by AC, but remember we are looking for AC. We're gonna make our AC the subject of the formula. This multiplied by sine theta is AC sine theta, and BC multiplied by 1, it's BC. Therefore we divide both sides by sine theta. AC is equals to BC over sine theta. Therefore, what is the magnitude of BC? BC is equals to x, and theta, it's theta right there. So x over sine theta, and therefore this is the magnitude of AC in terms of x and theta. So that's the answer for question number 7.1.1. okay, for 2 marks. And in 7.1.2 it says calculate the length of CE in terms of x. Again, go check where is CE located. Now CE is located again on two triangles. On ACE triangle, that's whereby your length CE is located, and it is also located on this triangle CED, meaning it's a common side for these two triangles. But they say to you, calculate the length of CE in terms of x, meaning this triangle, you're going to ask yourself, this triangle, does it have x? Yes, because we have already determined the AC in terms of x and theta. So it has x. So now, if I want to use this triangle to determine CE, let me check. This triangle, it doesn't have 90 degrees in it. So for a fact that it doesn't have 90 degrees in it, you're going to use area rule or sine rule or cosine rule, because it doesn't have 90 degrees. So in order for you to determine the sides or the angles of this triangle, it doesn't have 90 degrees, you're going to use all of those rules that I have just mentioned. So if you use sine rule to determine the length of CE, you're not given this magnitude, you're not given the magnitude of this side. So it won't be possible for you, because you have this angle, you are not given this, you are also not given the opposite side, the opposite angle of the side that you are looking for. So it's totally out. If you use your cosine rule, this is the adjacent angle, you're not given the opposite side of the adjacent angle, so you won't be able to use it. Now, okay, you see that you failed to use this triangle to determine the length of CE. Therefore, let's talk about this triangle now. Triangle CED. Can I use this triangle to determine my CE in terms of x? Yes, I have x, which is x plus 2, which is this side. Now, if I use this, look, you're gonna use trig functions or Pythagoras theorem. You're not gonna use Pythagoras theorem because you're not given this side, you have this side, you are looking for that side. So Pythagoras theorem is not what you are going to use. And again, it's 90 degrees, meaning we're gonna use the trig functions to determine CE. So you are given this, you are given that. So we're gonna use its hypotenuse, right? And this is adjacent to this angle which is given. So we're gonna have adjacent over hypotenuse because it's opposite to 90 degrees. So in order for us to determine AC 7.1.2, in order for us to determine CE, we're gonna say sine 60 degree cos 60 degrees is cos to adjacent over hypotenuse. Cos 60 degrees is equals to adjacent, in this case is CD, hypotenuse is CE. CD over CE, and we are looking for CE. We're gonna make CE subject of the formula. CE multiplied by cos 60, it's CE cos 60 degrees, and then here we have 1 CD multiplied by 1, it's CD. We are looking for CE. We divide both sides by cos 60 degrees. CD is equals to cos 60 degrees, and therefore what is the magnitude of CD? The magnitude of CD is x plus 2, so we have x plus 2. And what is the magnitude of cos 60 degrees? The magnitude of cos 60 degrees is basically divided by 1 over 2, and therefore we have x plus 2 multiplied by 2, and therefore we have 2x plus 4. Therefore this will be the magnitude of CE for 7.1.2. Okay, right. Now let us continue with 7.2. 7.2, it says, show that the area of the roof of triangle ACE is given by, meaning the area of the area of roof triangle ACE. Go to your diagram. ACE, meaning we want the area of this triangle. Like I said, this triangle, it doesn't have 90 degrees in it. So if we were asked to determine the area of this triangle, we're gonna the formula that we were going to use is half base multiplied by height. Half base multiplied by height, because it has 90 degrees. So this triangle, it doesn't have 90 degrees, we're not gonna use half base multiplied by height, which is the area formula to determine the area of a triangle. So we're gonna use area rule. Now, what is the formula for area rule? Based on this triangle, we're gonna determine the formula of area rule for this triangle. Now let's check. They said we should determine the area, right? So we have the adjacent angle, guys. We have the adjacent angle. We're gonna use the adjacent, not the adjacent angle. We have this angle. We're gonna use the adjacent sides, okay, to determine the area of this triangle. So now we're gonna say 7.2 area of triangle ACE, area of triangle ACE is equals to how much? We're gonna use this angle and the adjacent sides to this angle. We're gonna say it's half. This is area rule, it's half. Adjacent side is AC and CE. AC multiplied by CE multiplied by sine this adjacent angle, which is angle C, multiplied by sine angle C. So we're gonna have half AC. We have already determined the magnitude of AC, remember, on this question, which is x over sine theta multiplied by CE. It's 2x plus 4. It's 2x plus 4, and then sine angle C. Sine angle C is equals to 2 theta. It's gonna be 2 theta, and therefore let's work it out. We're gonna say this multiplied by this, it's 1 multiplied by x, it's x. So let me do this, let me put this up here. 1 multiplied by x is x, 2 multiplied by this is 2 sine theta, and then we have 2x plus 4, and then this is a double angle, matriculants, it's a double angle, it's 2 sine theta cos theta, and therefore these cancels, these 2 cancels 2, and therefore we have x, we have 2x plus 4, we left with, remember this 2 cancel that 2, we left with cos theta, and therefore let's take out the common factor, which is 2. It's 2 multiplied by x is 2x, x plus 2 cos theta, and therefore that will be the area of this triangle. So we determine the area of triangle ACE just the way they wanted us to do it. Can you see that? Now let's move on to 7.3, which is the last question. 7.3, it says, if theta is equals to 55 degrees, BC is 12 meters, calculate the length of AE. So where is AE? AE, okay? So we're gonna use cosine rule to determine the length of AE, or yeah, we're not gonna be able to use sine rule. 7.3, we're gonna say to determine AE, we're gonna use cosine rule because we have the opposite side. So meaning AE squared is equals to these sides, AC squared plus CE squared is equals to AC squared plus CE squared minus 2 times AC times CE cos angle C. And therefore, what is the magnitude of AC? Remember, you are okay. AC, we have already determined AC, right? AC is equals to x sine theta. X sine theta to the power of 2. CE is equals to 2x plus 4. CE is equals to 2x plus 4 minus 2. AC is x over sine theta. CE is 2x plus 4. Cos angle C is 2 theta. I'm sorry about my mess. It's 2 theta, and therefore remember we are told that BC is equals to 12 meters. Now guys, look, this is BC, okay? BC is equals to 12 meters, meaning x is equals to 12 meters. We have 12 sine, and theta is equals to 55 degrees. Sine 55 degrees to the power of 2 plus 2, x is equals to 12 plus 4 minus 2, x is equals to 12 divided by sine 55 degrees. 2 multiplied by 12, let me say plus 4. We have cos 55 degrees, and therefore remember we have AE squared this side. We're gonna say, I'm sorry about my mess, we're gonna say on our calculator 12 sine 55 degrees to the power to the power of 2 plus 2 multiplied by 12 plus 4 to the power of 2. Oh, I left the squared here. It's supposed to be squared. Here. To the power of 2 minus 2 multiplied by 12 divided by sine 55. Multiply by 2 times another 12 plus 4 cos plus 4 cos 2 multiplied by 55, and this is the answer 1279,18167. Because we are looking for AE, not AE squared, we take root sign on both sides. Therefore the magnitude of AE is equals to, we take the answer under the root sign, is equals to 35, they didn't indicate to how many places, we just want to round it to 2 decimal places. 35,77 meters, because they used units meters.